So, in our project, we use a photodiode which is in my left hand and a IR LED in my right hand that emits IR rays. Now, we are going to see what are the changes occurs to the photodiode when it receives the IR rays. I bias the IR LED using a 330 ohm resistor and connect it to my breadboard power rails. I use 5 volt in my breadboard. The yellow jumper wire carries plus 5 volt and the green one is ground or 0 volt. As you can see, the IR LED lights up and I connect the photodiode in reverse polarity to the multimeter, and if I measure the voltage, now it is showing 0 volt. When I bring the photodiode close to the IR LED, as you can see, some voltage builds up to its terminal. Or if I show you the resistance when the photodiode is not receiving the IR rays, its resistance is greater than 2 mega ohm. But see, when it receives IR rays, as you can see, its resistance is decreased to around 500k or 600k. We use these properties to build our robot, and we need to understand another circuit which is called comparator. Symbol represent a op amp. A comparator is an open loop op amp. We bias it with plus VCC. Let's say I take 5 volt and minus VCC. Let's say I take ground. So it has two input VP with positive sign. It is called non-inverting, and VN it is called inverting terminal. When we apply voltage VP greater than VN, the output voltage will be plus VCC. In our case 5 volt, and when we apply voltage VN greater than VP, the output will be minus VCC, in our case ground. IC741 provides a op amp, and it is a 8 pin IC, and the pin configuration I have already drawn. So this is a 741 IC. I bias it with 5 volt and ground, and I connect LED to its output to indicate whether it is in plus VCC or minus VCC state. And to demonstrate the comparator working, I need two voltage source for the input. For that, I use two 10k preset to create voltage divider, and I can vary 0 to 5 volt by adjusting the preset. Black wire is coming from the first preset, and I set this voltage to 2 volt as you can see in the multimeter, and I set 3 volt to the red wire which is coming out from the second preset. Now I powered the IC. The LED turned on because no input is there, and the output can be plus VCC or minus VCC arbitrarily, right? Now I connect the red wire which is 3 volt to the pin 2 and the black wire which is 2 volt into pin 3. See, the LED turned off because the voltage of pin 2 is greater than the pin 3, and then I increase the black wire voltage above 3 volt by adjusting the preset. Now see, the LED turned on because the voltage of pin 3 now greater than pin 2, so the output will 5 volt, right? So that is how a comparator works. Now I connect the IR LED in forward bias and the photodiode in reverse bias to the 5 volt supply. So when the photodiode is not receiving the IR rays, its resistance is high, so it acts as open circuit as you can see in the diagram, and the 5 volt will come out from the other terminal of the resistance. But when it receives IR rays, the resistance becomes smaller, and I assume it to 600k, and if I apply voltage divider rule, I will get 2 volt. Now I connect this terminal to the inverting terminal of the op amp, and in non-inverting terminal I give 3 volt. See, in the not receiving case, inverting terminal's voltage is greater than the non-inverting terminal's voltage. That's why the output will be 0 volt. And the other case, when it receives IR rays, the non-inverting terminal's voltage is actually greater than the inverting terminal. That's why the output will be 5 volt. But there is a problem on driving a motor with this 5 volt, because the output of the op amp only provides 20 mA, which is not enough current to drive the motor. For that, I use a N-channel MOSFET as a switch. IRF-Z44N N-channel MOSFET can do the job nicely. It can handle 49 ampere, and it provides the maximum drain to source voltage 55 volt, and its threshold voltage is 3 volt. So here if I give 0 volt in gate, then the motor remains off, but when we give 5 volt, the motor will be turned on. So I have told you so much theory, so I started building the circuit on a breadboard. Remember, practically slightly different from the theory. For example, in IR LED biasing, I calculated the control signal which is fetched to the comparator inverting terminal is 2 volt, but in practical it is other than 2 volt, because there I assume the photodiode only as a resistor, but it also acts as a voltage source. It gives some forward voltage of 0.6 to 0.7 volt. For this reason the control signal's voltage is other than 2 volt, and we have to give some other voltage than 3 volt to the non-inverting terminal of the op-amp by adjusting the preset to ensure that the comparator works fine. So in breadboard, making circuit is a bit difficult job because the problem of loose connection. Nevertheless, the circuit is working, and as you can see, when the IR rays gets reflected by the white paper and photodiode received it, the LED turned on. To drive the motor, I make the MOSFET circuit I showed you before, and additionally I add a pull-up resistor to drain to source to prevent automatical switching because of static charge. As you can see, this is also working like a charm. Now the only thing left is to solder the components permanently in a Vero board and making a housing for the robot. As you can see, after 2 hours of soldering, I made this board which contain LM324 IC, which has 4 op-amp, means 4 comparators, and separately I made IR photodiode pair in 4 small subboards. And these 2 MOSFET for driving the motors. I use a phone box and glue the motors and IR subboards into the box. I use 2 lithium-ion batteries, one is for driving the motors, another one with a boost converter, it is for the comparator and IR modules. Then the wiring part is left, and you can check my description for the wiring diagram, and then I glued all the wires as much clean as I can. Again I set the sensitivity of IR LEDs by adjusting the preset. But when I tested the robot, it is failed to follow the black line because the motor speed is very high and there is slightly delay between the IR rays stop sending the control signal to the comparator and the MOSFET to turn off the motor. For that, the robot couldn't follow the black line. So there is 2 solutions to this problem. One is I have to make the black line wider or decrease the motor speed. So the first solution is not convenient. So I have to decrease the motor speed. For that I need voltage controller, as motor speed is proportional to the voltage we supply, but I didn't have these ICs. So I used 3 diodes in series to create a suitable speed so that the robot can follow the line. But see, this process is not an efficient method to slow down a motor speed, and also the diode will generate a lot of it, and at last it is following the line. So I have been working and shooting these videos for 4 days, and you might see it only 10 to 12 minutes. So to support me, subscribe to my channel.